having multiple image classes, and how you can do a kind of pre-processing, and can divide it into different classes. If you want, you can separate it out in the form of uh, the training set and the validation set separately, and then you can write the code which will take the images directly from the folders on your system, and it will try to learn from that. So after covering this part, we'll be moving towards the concept of transfer learning, that there are some pre-trained architectures that have been trained on numerous or very huge amount of data. So the learning you can reuse for solving your problems, and how to do that, and how to do the fine tuning with your transfer learning, and how it can help you. And then we'll be talking about a concept called as automated machine learning, auto ML, and how it can be performed in deep learning with Keras. So there is uh, auto Keras API available. So that is basically a neural architecture search library. So that can be used for searching the best models. So you do not have to define the architecture, and you can use this API for looking for the best performing models. And then I'll be give you an overview that how you can get started with these machine learning models uh, on mobile devices. So there is a version of TensorFlow that is called TensorFlow Lite. You can embed your machine learning models with your mobile apps, and that can work perfectly fine on Android and iOS devices. So that is a really a lengthy topic, and for integration we need to first have the setup for Android or iOS, and then we need to have one app, and that can load that particular model. But definitely I'll tell you that how you can export your model to some format which is suitable for miniature devices. So during that, I would like to take up your questions. If you have any, specific questions related to these things, the auto ML, and the transfer learning, the the fine tuning, and the TensorFlow Lite, then please feel free to ask anytime if you have any question. Okay, so is the agenda clear?
Good morning, sir. Sharma, sir.
Yeah, very good morning.
Sir, this is Venkatesh from Andhra Pradesh. I have one doubt, sir.
Yeah, please.
Sir, actually, I mean, PG completed. I'm ready to research in machine learning, sir. I'm interested in machine learning.
Right.
Sir, for regular practicing, is there any online platform for machine learning, sir? I want to do regular practicing, sir.
Okay.
Why? Because in this session, in these those 5 days, I'm learned something, sir. I mean, what is machine learning and what and so and so. I mean, I know that minimum basics, sir, but I don't know the how to start the machine learning and how to the every step. Is there any platform, sir, for regular practicing?
Yeah. Definitely, there are lot many platforms, and the best way to learn anything or to get mastery over any skill is to try to solve some problem. So one way is just you are learning some concepts, you are learning that how the things happen. So initially that is hard to get started with, but the best learning happens when you try to solve some problem. So by the time you would be having an idea that what type of problems machine learning can solve, so it is best for solving pattern recognition problem. So that can be the classification or regression. And as far as the platform is concerned, like where we can get the fresh problems, or where we can find the data, or if we get stuck somewhere, then where we can find the help. So Kaggle is the best platform for that. Kaggle,
Sir, which
Kaggle. So that is the biggest platform for data scientists. You'll find many data sets available. There will be some live competitions, like if you reach one level of learning and you want to apply and test it, that how it can be used for solving real life problems. So you can pick up some challenge, you can participate there, you can come up with model, and you can share your model with the world, and if it is the best performing, then you can be awarded with the prizes in dollars. So you'll find there various data sets available based on the type of problem you want to solve, whether it is time series, it is classification, whether it is binary classification, multi-class classification, whether you need a data set of images, you need the data set of text. So based on that, you can pick up a data set. And as far as if you want to get started with some traditional and very low sized data sets, then there is UCI machine learning repository or data sets repository, where you will find hundreds of data sets to get started with. And the best part of this Kaggle platform is that you'll find tutorials as well. So if you just want to learn and if you just want to utilize it for for your learning, then you can find good tutorials over there.
Okay, sir. Thank.
So
That is the Keras platform, sir.
it is Kaggle, Kaggle. I would request the administrators to allow me to share my screen so that I can just share with you this website. Thank you so much. Okay, so the website that I told you is Kaggle, Kaggle. So what you can do, you can register here and you can make a profile of yours, so that if you want to save some of the resources, then those resources will be available to you. So
Screen is not visible, sir.
okay, screen is not visible.
Yeah, yes, sir.
No, it is visible.
Okay, can you see this Kaggle web page?
No, sir. Here, now.
Okay, so this is the website, and I think it is the most popular resource for among the data science community. And here you can find anything that you need. If you want to practice, if you need some data sets, then you can go and find some data sets. If you want to get some tutorials, so that would be available in the form of notebooks. If you want to discuss something, then you'll find discussion platforms, and even you can find here different courses and a lot many other things. So let's talk about that, what type of data sets are available on Kaggle. So there are different types of data sets available, and you can see the live competitions happening. And these are some of the popular data sets, and there are thousands of categories of the data sets. And I think once you register, then you can do some sort of searching or filter. Yes, this is the filter. And here, based on what type of problem you want to solve, what type of data set you want, so that can be in CSV format, JSON format, SQLite, or BigQuery. And with what licenses you want, whether it should be freely available for using it for commercial purposes and all. So based on that, you can just filter it out. And you can look for certain tags, like in what domain you want to look the data sets for, whether it is earth and nature, whether it is for computer science, it is arts and entertainment. So based on this filtering, you can get different types of data sets. You can play around with those data sets. Suppose you are working with classification, then try to get some classification problem. If you are working in text processing, then you can find the data sets in the text processing. So this is definitely one of the most useful platform where you need to register, and then you'll get lots of things with you. If you have your own data set, then you can even post it and can even organize challenges for that. And there are various competitions, so you can see that if there is something where I can apply my learning, and even there are prizes, like this is for $1 lakh, it is for $30,000. If your model performs better than the others, then definitely you can get it. So it is very useful resource. Other useful resource is GitHub. You'll find various repositories by various people there on different topics. And another useful repository of the data sets is UCI repository. So it is, there are different data sets available here. So based on, means what type of problem you want to solve. So for beginners, it is the best source to get started with. If you want to solve the classification problem, then 417 data sets are available. For regression, 129 data sets are available. For clustering, 112 data sets are available. What type of data you want, whether it should contain categorical, numerical, or mixed type of values. Data type, whether it is multivariate, univariate, sequential, or what type of data you want to work with, in which area you want to work with. So there are, I think, hundreds of data sets available. You download it, and they are very kind of legacy data sets with the moderate size, ranging from KB to MBs to few GBs. So you can download it, and you can get started with this. So I recommend you three platforms for practicing data science machine learning. The first one is Kaggle, the second one is UCI machine learning repository, and the third one is GitHub. So these will be sufficient for you to get started with. Is it clear?
It is very clear, sir. Thank you, sir. Thank you very much for that giving a lot of information, sir. And one
You're
more
welcome.
doubt, sir.
Yeah, please.
Sir, actually, I'm prepared one app, sir. I'm developed one app. Sir, will
Yeah.
you integrate machine learning to that app, sir?
Yeah, definitely you can integrate that, and we are going to discuss in the later part. Since you know that the integration with Android, so first we need to develop the app, and we need to do some coding at the level of Android, and then we need to import it. So it will take, I think, 3 4 hours to explain everything
Okay.
for that part only. But I'll tell you that
Okay.
how you can export your model so that it is compatible with iOS and the Android applications. And then I'll let you know that what are the different tools and technologies, and what can be done as far as machine learning on running the machine learning models on mobile devices is concerned. So there is a tool for deep learning that is called TensorFlow Lite, and it has its own dedicated website with various examples. Like if you want to create a image classifier, and the app should integrate on your mobile, so everything, means starting to end, you'll get all these steps in a very lucid manner. But definitely it will take some time, 3 4 hours or even a day to create one app. So I'll let you know about that. You can use TensorFlow Lite for that. Okay,
Okay, sir.
so now I think most of the people have joined. So now let's get started with something very exciting, that how you can create your own data set, and how you can get started with training of your own model, and how transfer learning can be used.
Sir,
So
1 second, please.
yeah, please.
Yeah, before you start, let us formally introduce you one more time to the audience.
Thank you, thank you. Please go ahead.
Yeah. And Beulah, give me the privilege that I'll introduce the speaker.
Yeah, please.
So it is my pleasure to invite Dr. Chandramani Sharma once again to our FGP. There were two exciting sessions. Dr. Chandramani Sharma is having more than a decade of experience in industry and academia. He did his master's in computer science from DAVV Indore and got into the doctoral bandwagon at Indian Institute of Technology, Delhi, under the able mentorship of Professor V. Raghavan. He started his career as an enterprise application developer with Syscom Incorporation, having associated with a couple of prestigious organizations like Capgemini in past. He is currently working in Department of Informatics, University of Petroleum and Energy Studies, Uttarakhand. He has mentored many successful startups and has served as one of the founding directors for CDD Global Solutions. He has convened three successful international hackathons with academia and industry collaborators such as IBM, STPI, Cardiff University, Intel, etc. He is also serving as a mentor and advisor at IEEE ACIT. Areas of interest include data analytics, machine learning, rural development, entrepreneurship, and sustainable design. He has published some research papers, books, and articles with reputed publishers. He enjoys reading, writing, and networking with people. More than that, he has the lot of passion to teach that we are directly viewing it from yesterday. Even a small doubt, he explains it with detailed, elaboratively, so that the whoever asked the doubt is very well clear about it. And we are really grateful to you, sir, for having you taking participate in our FGP. And I'm really thankful to you once again for accepting our invitation and giving your valuable ideas and your knowledge to our participants. Thank you, sir. Over to you.
Thank you so much, sir, for such a nice introduction. So now let's get back to something which may be of common interest, because as each one of you want to create your own deep learning model, so there are certain things that you won't find at one place. That is something that I have explored on my own. So out of my experience, I'll be telling you some of the tools. The first thing is that how you can create a data set. So we'll be talking about the problem of image classification, and we'll be creating our own image data set instead of using the pre-existing ones. And for that, there are certain couple of steps that you can do. For if you want to create your own data set and that is not existing. So one thing is that you need to go in the ground, and you need to just create the data set. Suppose you just want to create a data set for disease classification in the crops, then you need to go to the fields, and then you need to click the photographs, and then you need to do some sort of pre-processing with it, and then you can train it. But another way is that if you are not using it for commercial purpose, and you just want to use it for exploring certain things, then you can utilize the data available on World Wide Web, and you can download images from there. You can do some sort of pre-processing, but that cannot be definitely used for for some commercial purposes, because some of the images may be copyrighted, and you cannot redistribute that for for uh, further uses. But definitely for getting started with, I'm telling you this trick and some tools. So for this, for creating our own data set, what we just need one Chrome browser, and we'll be using one extension from this Chrome browser. So okay, so currently I'm working on this Chrome browser, and let me just go to the extension. So I'll be installing one extension in this Chrome browser. So from these three dots, you just go to more tools, and here you'll get the extensions. Just open it, and here you need to just install one extension, that is download all images. So it is already installed on my system. How you can install it? Here, after clicking on extensions at the top left corner, okay, so you'll get here Chrome Web Store. So there are various extensions available here that you can look for. So we'll be installing one extension here and search the web store. So download all images is the name of extension that we want to look for. And from here, there are themes and extensions. We are just interested in extensions. And then here it comes. So this is the zip, icon thumbnail coming up here. And this is the extension that we need to integrate with our, Chrome browser. And just click here, and it is already integrated with my browser. But if you are integrating it, then you'll get here an option of adding it to the Chrome. So once it is added, okay, so what next you need to do, you just need to look for some image data. Suppose you are interested in finding the difference, or you are just want to want a classifier that will classify whether an image is of a spoon or plate. So maybe that data set it may not be available on the internet, and you want to solve this particular task. For that, you need to create your own data set. Or suppose you want to create some system whether a person is wearing helmet or not, and if this data set is not available, then you can create your own data set. So no matter what type of problem you want to solve, you can go with creating your own data set. And then we'll see that how we can train our own system deep learning kind of classifier, which can be used for training. Okay, so what is the next step? I just need to go to images.google.com. So this is a search feature provided by Google, where whatever you type, you'll get just the images back. So whatever type of data you want to look for, you just need to type here, and you'll get the response in the form of images. For the time being, I just want to download some images of the faces. So I'm interested in looking for the human faces, and I want to classifier that will detect whether it is a face or not. So you can go with any categories, whether it is some disease, whether it is some object, or it is anything that you want to train your classifier with. Just search it. So here you'll find various faces. And so what next you need to do, at one time in Google Chrome, around 350 images are loaded. So if you want to just get more images, so what you need to do, you just need to scroll it, and as many as images you can want, because if it is a deep learning system, then at least 2000, 3000 images should be there, so that you can get some sort of accuracy with the various various differences in the types of the images. So here you are getting the variety, like there are female faces, male faces with different creeds and complexions. So you are getting a good variety. So how you can download these entire images? So for that, we have this extension. This extension is available, and on the right side of the window, you can see that there is a small icon appearing, that is zip. So just click here, and it will start downloading the images. So it is 20, 57, 65, 68. So these many images have been downloaded. It will download all of them. If you want some small data, just click here, and it will stop downloading. And our data set would be available with this downloads folder. Okay, so this is the folder, the zip folder that is just downloaded. What we need to do, we just need to, since it is zipped, so we just need to uncompress it. Okay, extract here. Okay, so it has been extracted, and there are different images of the faces that have been downloaded. So what is the next thing? Are you able to see the desktop or the folder where I am right now? Some images.
Yes, sir.
Yes, sir.
Okay. So these are the images, but there is problem with this data set because it downloaded everything which was available on the page. So there are some of the images that may not belong to a face. Like this is one example of that. This is another example of that, and this is something like this. So I'm using Ubuntu, and it is showing me the thumbnails. And this is the good idea that for the images for which you cannot see a kind of a face thumbnail, delete those images. So this is something that you required for data cleansing, because you are downloading it from the internet, and you are getting some of the corrupt data, or some of the data which cannot be used as the JPG extension, or it could not be converted. So select those images. So these are just the images which are not having a face thumbnail. So I'll be selecting all those images. This is also not a face. I just need to press Control and need to select it. And this is also not the thumbnail. I need to delete it, delete it. So first I need to select them, because they may be, some non-compatible data pieces that may cause problems at the time of training. So we'll play safe, and we'll just go ahead with those images for which we can see the faces in their thumbnails. It means that they are perfectly okay with the JPG compression. So we can go with this, or we can just delete it. This is also a face, but not sure whether it will work with the human face detector or not. So this is something that you need to do. So based on it may take some time. So just delete it. And now these are some of the images that can form the part of our data set. Okay. So, all right. So how many images are we having right now? So there are 174 items with us, and you may need some more images, but it is just a kind of demo that I'm showing you, that how you can go ahead. But it will take some time to gather, suppose 10,000 or 5,000 images, but that you can do really rapidly. And so just rename it with name faces. So here are there are our faces. So here you can see that this is our data set, but this data set is having the images in different dimensions. And what is the best thing to convert these images in the uniform dimension? Like some image maybe 720 into 60, some image maybe of 150 into 150. So they are heterogeneous in dimension. So placing them into the same dimension is a good idea. Otherwise it can be done even at the runtime when you are reading these images, and you can set the target size on the go. But it is a good idea that we have a neat and clean data set which is numbered uniformly. So here you can see that the files are numbered differently, and even the long names can cause problems while reading. So we'll be just uniformly naming them starting from image 1 to 174, and we'll be keeping their size uniformly 150 by 150, because our system will be requiring images which are in dimension of 150 by 150. So this is our raw data set. I'm just cutting it from here and just taking it to my desktop. Okay, so what I'll do with this, I'll go with a very simple Python scripting file that will take these images one by one from this particular folder, and will resize it in the form of 150 by 150, and will save those resized images in a resized folder. So I'll be doing it offline, but you can do this with the Google Colab as well. You just need to provide the permission to access your drive for by just writing 2 lines of code, and the script that I'll be using that is also available in this drive. Okay, so there is a folder CUTN. I'll be sharing this particular folder with you all, and it contains all the resources and one custom data set as well. So you can download it and can practice it, or even can just upload it on your drive and can practice with me if you want. So this particular okay, imresize.ipynb. So this is the file, scripting file that can be used for resizing and saving the images with uniform names. Okay, let's do it offline instead of doing this thing online, because I'll have to upload it, and then it will take more time if done online, because it will consume some bandwidth and will be slower. So I'm just doing this because this is just IPynb file, so I need to open Jupyter Notebook on my local system. So let me start my Jupyter Notebook. Okay, Google Colab also work in the background with this Jupyter Notebook, and that is something which is used for creating interactive Python notebooks, and it will open in the browser. Okay, so this is the Jupyter Notebook. It is referring to the root folder. I need to go to my desktop because there is IPynb file, and that is imresize.ipynb. So this is the file. So it contains just a few lines of scripting code that will be accessing the files from the local directory, and will be resizing and saving them back. So this is just the file. This is these are just few 7-8 lines of code. So I have specified here the path, and the path is already referring to this this faces folder. And after reading the files from this directory, so there are some, we are using this OS and sys package in the available with Python for doing some system level and operating system level operations, and that is very easy. So item in dirs. So dirs is referring to this particular directory, and it will be reading everything. So whatever files and directories are available, and it will just check whether if the item is file, then what it will do, it will just resize that into 150 by 150, do some sort of anti-aliasing. So that is just a image level operation to smooth the image, and then I'll be converting into RGB, and it will be saved with this particular save command. So it will be saved path, and then this is the directory that I need to create with name resized, and whatever image is there, so it will be saving uh, with extension .jpg, and the quality I'm keeping here 90%. I can even keep here 100%. So what I need to create now, in this particular faces folder, I just need to create one resized folder so that my altered images can be saved there. Okay, so this is the
Time to do is to call this converter and convert our model. For now,
okay, so just need to create one folder here and need to rename it resized, and that's it. So the script will read all the files from here, and what it'll do, it'll just save the files after renaming in the sequence of 1 2 3 4 5 up to 174, and it will be saving it there. So let me just refresh and can. Okay, so let's try to execute this particular code. And for executing here in Colab, we get the play button here, but in Jupyter Notebook, we'll have to run it from here. And I hope everything went fine. And this is resized folder. Okay, so what it has done, it has saved all the images. It has renamed all the images starting from 1 2 3 4 5, and the last one is 174, and all the images now are of the same size. So if I open it and see the size, okay, so this is the first image, second image. Okay, so this is what our data set looks like, and all these standard data sets are available like that. Like if you work with MNIST, then it has the dimension of 28 by 28, and if we talk about CIFAR, so it has its own predefined dimension. If we talk about other data sets, so they are uniformly resized. So that's it, how you can create your data set. And this is just one class. So if you want a binary classifier, still you need at least two classes. If you just want to detect faces, then you need to have two classes. One is belonging to the faces and another one should represent non faces or the backgrounds. So you need to collect those images as well. And if you want multi-class classification, so even if as many classes are there, so accordingly you need to create those many folders in your data set, and you need to create it in one directory. Is it clear that how to create your data set?
Yes, sir.
Okay, so this particular script file is available in this CUTN, this folder, which is that you can use later on. I'll be sharing it with you all. And
Sir, excuse me, sir. Sir, the last point, please again repeat the binary class and the multi-class classifier. That point.
okay, so what is there? Suppose if you want to create one detector. So if you talk about face detection and face recognition, so what is the difference between these two? If you just want to create some detector, it means it will just detect whether the face is existing in the image or not. But if you want to create some face recognizer, it means there will be many people and you need to recognize whose face is that. So the binary classification problem will be the face detection, though there is just one class whether face is there or not. So or not is also the another class. So even if you are working, you are interested in one category of the object to identify, then you need to have two classes. So for face detection, you'll be creating two classes. One is of the faces and another one will be belonging to the backgrounds. Or suppose if you want to create a helmet detector classifier, then you'll be having two classes. One is belonging to the helmets and another one that is representing some background. And if it is a multi-class classification problem, then definitely the number of classes that you are dealing with, you'll be having those many folders. Like in CIFAR 10, there are 10 different categories of the objects. Like there is truck, there is airplane, and there are other I think elephant. So there are different 10 classes of the objects, and then you need to have your data stored in 10 different folders. So that's it. That if you need just a detector, so that will be a binary classifier. having two folders. If it is a multi-class classification, then you do not need to have background images. If there are three types of objects, then it will just work perfectly, and it will try to discriminate among those classes. Okay, so now let's train our own model. And for that, there is this data set that I've created in the same way. I have not taken it from anywhere, or it is not a standard data set. And what this data set is having, so there are two classes. One is belonging to lions, and another one is cage. So it will be trying to learn that what is a lion and what is a cage. So since the number of images in this data set is moderate, I think around 650 total images are there in this data set, having 300 and 300 plus images in both of these categories. So that is not very large, and I have deliberately taken this these classes so that there is variation. So lion is distinctive from cage. But if I would have taken some of the some of the similar categories of the objects like lion and tiger or lion and cat, so it won't have given me that much accuracy, because there are lot many things common. And uh, with some data set that is just having few hundreds of images, the accuracy may not be that impressive. But for the time being, we are not focused on improving the accuracy. Definitely you need to have larger data set for that. But here we are just learning that how you can create your small data set and how you can train your model on that. So that is something that the people who are starting their journey for machine learning and deep learning find difficult. Okay, so this is our data set having two classes, lions and cage. And let me just see the code to train a convolutional neural network architecture on this particular category. So there is a file, my model training.ipynb. I am opening it in Google Colab. Okay, so this particular data set is available in my Google Drive. And to access your Google Drive, to access the data from your Google Drive, Google asks you to provide it access. So these two lines you need to write: from google.colab import drive, and you need to mount it. So if you are doing it first time, then it is already mounted on my system. I have already provided you the access. Otherwise it will ask you a passcode. It will give you here a URL. You need to just click there, and then whatever Gmail account you have logged in, you need to yeah, it is asking. That's good thing. So I just need to click here, and I need to just pick up my email ID. It is asking, the password is already saved there, so I need to allow it. And this is a passcode. So that has been copied after clicking here. I need to come back. I need to copy this passcode and then press enter. So what it will do, content and drive, you do not see it. It is because you are working here on some virtual machine. So you just have access to your my drive. But even before that my drive, there are various users, and there are these are the locations that you cannot directly see in your drive, but you need to mount it. So this is a kind of route, and from there you can just access your files. So what next we are going to create? We are just creating a simple CNN architecture. So for that we have imported layers and these models. Let me just run it. And here is a sequential convolutional neural network. So hope you understand the meaning of Conv2D, max pooling, and this flattening and dropout layers and the dense layers. So as I told you yesterday, that with the Keras we can create two types of models. We have two types of APIs available. One is called sequential, where the layers are stacked up sequentially, and another one is using the model class, so for creating kind of non-linear or more powerful models that we did yesterday when we discussed autoencoders. So it is very simple. You are just creating an instance of this sequential model class, and then you are just adding layers to this. So first we are adding a convolutional 2D layer, which will be having these 32 filters, and the filter size or the kernel size is going to be 3 by 3, and activation is ReLU, and our input shape means the images that we are working with is 150 by 150, and it is RGB or 3 channel images. So we are this is our kind of input layer which will be reading the data directly. And next we are applying max pooling. So max pooling is just a kind of downsampling process which will be reducing the size. So it will be taking the grids of the size 2 by 2 and will be selecting the maximum value and will be reducing the size. And then we are further applying convolutional 2D, and here we are taking 64 filters of size 3 by 3 and again applying ReLU as the activation, then again max pooling. So there is a sequence of uh, convolution pooling, convolution pooling, convolution pooling, and once we learn enough features, then we try to flatten it, because here we are applying dropout. So dropout is just a kind of mechanism to mitigate the problem of overfitting, because when your data is small and it is doing back propagation and updating the weights, and the learning is happening at that particular time. So if the data set is very small, so what network can do, network can memorize the instances. So instead of generalization, it may try to memorize. So if you just ask a child that you need to do the sum of 2 plus 3, and you are just giving him one example and tell him that it is 5. So if you are just providing one example and you are explaining the process as well, so what the student can do, instead of understanding the underlying process, student may simply memorize that if it is 2 plus 5, then answer is 2 plus 3, then answer is 5. So the student is not generalizing. If you change the values, that if it is 2 plus 6, what will be the answer. So if the data set is limited, then the neural networks or even the convolutional networks may tend to memorize the data. So for that, you may try to add various mechanisms for overcoming the problem of this overfitting. So you can have regularization, you can have the dropping out of some of the neurons, that you can nullify the 50% of the neurons, so they won't be contributing. So that is just a mechanism for overcoming this overfitting problem. And what you are doing after this dropout, you are just creating one dense layer having 512 neurons. And at last, since it is just a binary classification problem, so this is your output layer, and one neuron can be used for binary classification. So that can represent the two classes. But if you are having suppose three classes, then the number of neurons in the output layer will be 3. If there are 10 classes, then it will represent the 3. If there are 100 classes, it will represent the 100 classes. So whatever we have defined here, so that is something uh, you know there is no predefined rule for that, but most of the existing architectures, they follow this particular pattern, that first they do convolution and then they pool, then they do convolution and then they pool. And in this way, the sequence and the number of these iterations may create variations, but this is somehow a kind of random architecture that we have created, and we just want to train our system. And at the last layer, we just want the output in the form of binary. So here we are using the sigmoid, which ranges from 0 to 1. And after creating this model, so this model will be created. So let me just, this is the architecture, that what are the different architectures, and here there are the different parameters, and none is representing here the batch, and the different parameters. So these are the number of parameters are coming after each layer, and the total number of parameters, it means total number of weights that you are going to deal with is around this 3,45,000 with this simple architecture. And even if you go with other architectures, so there can be millions of trainable parameters or weights and biases that you are dealing with. So this is just the architecture. So that is the common. The most interesting part is that how we can read the data from the directories and how we can pass it to the training. So that is something we are going to discuss. And here we are importing the optimizers and then trying to compile our model. So the loss function here is binary cross entropy, because we are dealing with binary classification, where there are just two classes. And optimizer is RMS prop. So you just can write it RMS prop in single quotes. But here we are customizing one hyperparameter, and that is learning rate. So with RMS prop, it is used with various built-in architectures, and the learning rate, if it is in the order of 10 raised to power minus 4, means 0.0001. So it gives best results with that. So that is something which is a heuristic coming from Stack Overflow, that what should be the value of learning rate when we are applying RMS prop. So it works with best with that, and it will be checking the accuracy, that how well the model is performing. So there are various types of metrics available for checking the performance. So this is how you compile your data. Now this particular code is very interesting, and here I'll be using image data generator class. So Keras provides you three types of data that you can work with. Either you can work with NumPy arrays, or you can work with the built-in data set objects, or you can work with data generators. So you can generate, or you can deal with any type of data. So here it is from the pre-processing. So we are importing this package image, and from there we are importing this image data generator. So it will be generating our data. It will be flowing from the directory that will be providing the path, and then it will be sending that particular data for the training. So we have created two variables, data train underscore data gen and test underscore uh, data gen. So test underscore data gen is something. So here we will not be using this test underscore data set gen, because for that you need to have the segregation into two folders. One is your training data, and another one is the validation or the testing data. So I think it would not be required. And here we are just using train underscore generator. How this train underscore generator is working, it is loading the images from the directory. So the directory that we have provided here is this particular one. So it is the fully qualified path. So content and drive is the root, and my drive is your your Google Drive, and CUTN is the folder inside that, and CUTN underscore data set is the root directory where your classes are available. And the target side is 150 by 150, and it will be reading the images from the directory in the chunk of 20. So it will not be reading all the images in one go. It will be reading that in the batch size of 20. And the class mode is binary. So so since we are just having two classes, so we are keeping it binary. So you just need to create a data generator, and it will automatically load those images in the form of batches. And once you execute this particular code, So it will automatically identify that this particular folder CUTN underscore data set, it is containing 680 images, and those images are belonging to two classes. So how did it identify? It just looked at how many folders are there. Each folder is belonging to a separate class. And here we are just having just the train data. So you can create another data generator for test data as well. So the code will be same, and you just need to provide the path of your validation data for that. So it has identified that there are 680 images, and those are belonging to two different classes. And here the size is 150 by 150, and since we are taking it in the batches of 20, so it will be the final size of the generator will be 20 into 150 into 150. It means there are 20 images of size 150 cross 150 cross 3, and corresponding to those images there will be 20 labels, because we are dealing with 20 images. So the labels will be uh, decided with that, and it can work perfectly with categorical as well as the numerical labels automatically. And here we are just printing the size of our batches, that the batch size is having this 20 into 150 into 3, and there are 20 classes corresponding to the 20 class levels corresponding to 20 images. And what we can do now, here we are training our data set. So the training of our data set is model.fit generator. Since we have a fit function that can work with some numerical data, as we saw in the previous uh, examples. I think you have already had this session on basic convolutional neural networks. So here, instead of using simple plain fit function, what we are doing here fit generator. And this fit generator does not need the class level. Otherwise, fit function requires X and Y. So here we are just providing train underscore generator, and steps per epoch, that is 10 here. And it will decide that how many step will be it will convert. So it will be converting the entire data set according to that, and it will be completing one epoch in 10 steps. And the number of epochs is 5 here in this case. So okay. Okay, so model needs to be compiled first. Okay, so we skipped this step. And then okay, we have printed it, and then we need to okay, so it will complete one epoch in 10 different steps. And here you can see that how the accuracy and loss are changing. So after every step, there is change in accuracy and loss, and it will return some metadata, and that we are keeping in this history variable. So that will be using for plotting the loss and accuracy for this training. And here fit generator, just mind here that you do not have to provide here the classes, because it is automatically taking into consideration that the images which are coming in the batch sizes of 20 and their corresponding class levels. So if you just work with just a simple fit function, so it requires the X as well as Y, so that you need to segregate. And just after 3 epochs we are getting this. the 90% accuracy, and the loss is also decreasing. Okay, so this is the final output, having accuracy of 89.5, but still it may underfit, and that you can see that how the accuracy is fluctuating. So it is not kind of tending towards saturation. There is a from 68 we got 86, then we got 89, and then again 89 and 85. So this is somewhat there, but you need more data for training it. And once you have created this model, so you can save it and you can reuse this model without retraining your system. So for that, for saving your models, we have different formats available. It can be saved in the form of H5 extension. It can be saved in the form of JSON file, in the form of pickle, and other extensions are available. And later on, you can just load it. So saving the model is very simple. Either you can use just save command or save underscore model, and it will save it with this extension H5, which is a very popular extension for saving the model. So JSON and H5 models are extensively used for that, and later on you can reuse it. So when we'll be talking about that how to work with TensorFlow Lite, so only difference here will be in the format for which we save that. So there is TF Lite or TensorFlow Lite available, and you can create one extension for using on the mobile devices, and that can be imported there. So that is the only one line difference there. And here you can just print the accuracy and the loss, that how they're working. So this is coming up like this. So this is the training accuracy. Initially it is increasing. We have just these 5 epochs, and after one epoch it was 66, and then it just shot up to 89 or 85, and then there is a kind of saturation. So this is the ideal scenario that we want with our accuracy curve, that initially it should improve and then it should try to saturate. So it should not learn much from the data. So that is something that is also telling some sort of overfitting, that it has memorized the data. It may be the case. So you need more data, and this is the training loss that you are using it. So this is something very basic, that how you can get started with training your own model, and you can use some of the data augmentation techniques, because Keras or any deep learning library provides you end-to-end model training. It means you do not have to be dependent on any of the external data engineering pipelines to modify and pre-process your data. Most of the things you can do on the go. You have the capabilities to modify your data, for pre-process your data, because sometimes we want the variety in our data. Suppose there are certain images of the faces, we want it to be cropped, it to be tilted, it to be rotated, or we want to do certain things with that. We want to zoom, we want to horizontal flip, and we want some shifting on left and right. So we can do that, and that can be done at with this image data generator function. So it will generate the data set by doing these transformations on the image, so that you get a variety in the data, and it can learn various latent features available in the data set. So this is just an example for that how it can be used. But this is something that you can explore. So any doubt or any questions on this? Have you got it? Okay, do you have any question to ask?
Yes, sir. Please, sir. Good morning, sir. This is Victor, sir. Sir, my question is regarding the memorization part where you said when we computed the, please, sir, if you can go to the last graph, sir. Please,
Yeah.
yes, sir. Yes, sir, yes, sir, yes. How do we know that it has, it has memorized the data, that it did not actually, generalize properly, sir? Can you just explain that, please?
Okay, so what is happening, since our data set is very moderate, we are having two classes and we are just having 680 images. So what it is doing here, you can see that initially after the first epoch, the accuracy was 67 or something like that. And after the second epoch, it reached to somewhere 89, and then after that there is no improvement in the accuracy. So since if our data is having a variety, or even there is a huge data, then you will see that there will be certain fluctuations in the data set, and it will not try to linearize with such a small number of epochs. So here there is a doubt that it has memorized the data set. So whatever were the images, it had just identified, it had just learned everything from individual image, and whenever image is coming, it is able to assign them the labels. So this is one aspect of that, and the biggest challenge for any machine learning task, that what happens then when we are performing training, the training accuracy is very good, and when we perform kind of validation or test it on some unseen data, then uh, the accuracy doesn't happen to be that well. So for that, the first thing is that we need to have very large data. There should be the variety in the data, and definitely we should have separate validation data, which is quite different uh, from the from the data on which we are performing training. So yes, in this example, there is a fair suspicion that the model has overfitted, because just after five epochs it has linearized. So after the third epoch and the fifth epoch, so there is not much variation, and the line that we are getting is just linear.
Thank you, sir. Thank you, sir.
Is it clear? But if you want to validate it, then you can have a validation data set, or you can work with some unseen images, and then
Okay.
can see that how it is performing. So this accuracy is just the accuracy taken at the training time. You can have uh, a different folder with name validation, and can have two subfolders there corresponding to the validation data for loins and the cages, and then can see that how it is performing.
Sir,
Okay. Yes. Yes,
sir,
please.
sometimes the model or the classifier does misclassify the data. How to overcome with that problem?
Okay, so that is the limitation. So here, the when you look at this particular, thing, that the accuracy is just 89. So what you need to do, it means that out of 100 instances, it misclassified 11 instances. So that you can see that why it is having, whether it is due to the class imbalance, whether there is a particular class for which the model is not performing well, and you can look at various performance metrics. So for multi-class classification, confusion matrix can give you that aspect. You can use other things, like you can look at the F score, the precision, and the recall, and how it is doing. And after looking at, suppose, a confusion matrix, you see that there are 10 classes. So the accuracy of 9 classes is ever 90, but the accuracy of one class is just 40, and that 40% is making the overall accuracy of, suppose, somewhere 80 or something like that. So uh, for nine categories of the objects, it is performing well, but one category of the objects, it is not performing that good. So what can be the problem? Then you need to look into the data, whether there is imbalance in the data set. You are just having 1,000 images for rest of the nine categories, and you are just having 300 images for the category that is not performing. So obviously there is some class imbalance, and how you can overcome that class imbalance. So there are various strategies for that, and somewhere that you need to kind of do some sort of analysis on the data, and how that accuracy is fluctuating. So you need to look into that.
Means, we have to make changes in the data set as well as in make changes in the what features of the data.
Basically, deep learning is end-to-end learning. So here we do not have much control over that, how the features are being extracted, because
Okay.
the convolutional neural network is learning by itself. So maybe in the first layer it is learning the lines, and then the ovals, then it is detecting the edges, then it is trying to recognize the eyes. So the learning is happening on its own. So here we do not have the control on the features. But if you are working with traditional classifiers like SVM or KNN or random forests, so they need some sort of feature extraction as the as the preceding task. So there you can work on that, and because 70% of your effort goes with data, and 30% is just picking up a right model and deploying it, because data is more important in any task. If you have data and that is rightly natured and rightly formatted, then your 70% of the task is done. So you need to take the data very seriously. Its volume should be large enough. It should have proper variations. It should not have any class imbalances. If it is having some class imbalances, then there are techniques for mitigating that how you can do that, how you can normalize the effect of each of the classifier. For each of the classes, a kind of percentage based contribution from each of the classes in the overall accuracy. So yeah, there are different techniques for that, and the looking at the data and reprocessing it is very, very important, because 70% role is played by data and 30% is just on the models.
Oh, yes, sir. Yes, sir.
So what is the proportion in imbalanced data set? I mean, which
Uh,
similar, I mean, like with which proportion we can say it is an imbalance, like 70-30 or 60-40. I mean, the proportion we need to consider the balance.
Means for balancing class
Yeah,
imbalance, you are asking
yeah,
about that.
yes, sir. For example, I'm having 100 records. Out of that, 70 are one class, 30 are of one class.
Okay, so obviously there is class imbalance. So what is the ideal situation? That all the classes should have equal data, and it depends on the the volume of the data. If you are having lakhs of the images for each of the categories, then even if you are having 70,000 images in one category and 1 lakh images in another category, then it would not have much difference. Still there is a gap of 30,000 images. So it depends on the kind of denomination that you are working with, whether it is tens of thousands, whether it is hundreds of thousands, or what level you are working with. So obviously class imbalance is a problem, and that is found in in the scenario. Suppose you are just working with the detection of some rare disease, and that you are doing with some sort of image diagnosis. Then maybe that the images of the people who do not have that disease will be more, and the images of the people who have that disease will be less. So obviously there will be a class imbalance there, and there are techniques for overcoming that. That is a totally a different thread of data science, that how to overcome class imbalances based on the type of data that you are working with. Okay. Your voice is not audible. I'm not getting. I think someone is trying to speak, but it is not reaching me. Okay, you can just type in your question in the chat box. Maybe I can read it from there.
Sir,
Yes, please.
sir, actually, I was doing a course yesterday on the Coursera,
Yeah.
and in one of the module we had a binary classifier, image classifier,
Okay.
and he gave me two data set.
Okay.
One is a training data set, and another is a testing data set.
Yeah.
Now, in the training data set, we have two-person, one a male with blue coat, and one a
Okay.
female with black coat.
Okay.
And in another data set, it is reversed. That means the lady with the blue coat and the boy or the man with the black coat. And
Okay.
we have to train the model on the two data set. One is for boy
Okay.
and another is for girl in the
Okay.
training data set. Now
Okay.
I trained the model that I trained that binary classifier with the training data. That
Uh-huh.
means boy with blue coat, girl with black coat.
Okay.
Now now he gave me a testing data set. In the testing data set, the boy was with black coat and the girl was with blue coat. Now
Okay.
I am going to upload. I uploaded the testing data set. Now for
Okay.
testing data set, suppose I uploaded the picture of the boy, image of the boy.
Okay.
In the training data set, the boy has blue shirt, but in the testing data set, the boy has black shirt.
Okay.
So
So,
when I
yeah,
uploaded the image
we
of
have got
testing
about
data set,
the data set. So, what was the finding and what problem did you face?
sir, the finding was the boy when I uploaded the picture image of the boy, it was classifying me to the girl.
Okay.
So
And
that was my question here. The model is misclassifying.
yeah. And uh, okay. And what was the size of data set? Means how many images were there?
Sir, in the in that zip file, around 35 images were there.
Okay, 35 images were there. So possibly instead of learning the features of the female face and the man face,
Huh.
what it learned the shape and the
It,
color of the
it learned the
images.
shape, size, or color and the
Yeah,
background,
yeah.
but
So
it could not identify the face.
yes, and definitely it is not learning the face because the number of images is very less. So what you can do that whenever you are training your system and you just want to distinguish that whether the image belongs to a male or female.
Yes, yes, sir.
So there we need variety. We cannot
Okay,
just keep the color of clothing uniform. We need a
okay.
variety. We need different people wearing different kind of outfits and the different colors, the different ethnic the faces or the people with hair, without hair, and the variation even in the poses, some having the front looking, some having just the profile look. So that will create a variety. And once there are variations, and we want the system to learn the variations, not to memorize. So what it did, it just memorized the color and the other features, and it did not get to know the discriminatory features that form a male's face and a female's face.
Female face, yes, sir.
And since this the size of the data set is very moderate,
Yes,
and
sir.
definitely we cannot get good results when we are keeping the color same. Maybe it may learn from the color, but when we are having the variations in the clothing color, that it may not perform well on
Yes,
these
sir.
35 images. It is doing
Hmm.
well because we are keeping the colors as our primary feature.
Sir, Suppose we will go for 300 images instead of 35 images. Now let's assume that we take those 300 images with the same pattern. Let's say a boy with black shirt and a girl with blue shirt in the testing data.
Yes, yes,
In
we can do. But the example that I've just taken is also having 680 images, and that is not, a very acceptable size of the data set. And what I've done here, that I have taken the object categories to be quite distinctive, because the cage is quite distinctive from the loin. But if you are taking male and female, then you need at least 10,000 images for each category
okay,
to get, because the cats and dogs data set that we'll be discussing
yes,
contains about 70,000 or 60,000 images, and then it is able to discriminate whether it is a dog or it is cat. In the
okay,
same way, male and female faces may be very resembling, and you need to have that discrimination and distinction in your data set.
okay, sir. So everything it depends upon our data set.
Yes, yes, because data is diamond.
Yes, sir. Yes, sir.
It is even not
That's
gold.
why
It is
I was
diamond.
totally confused because it was a he mentioned that it was a binary classifier and he used the deep learning model.
Yes, yes, and that is something, means if you participate in various Kaggle competitions, so they do it like this. So they will ask you to train, and they will do the testing on their own, and then will let you know that how your model is performing. So
Yes, sir.
definitely
Yes.
there need to be variations, and the actual beauty of any trained classifier is to work fine with the testing data, which is unseen and which is not the part of your training.
Hmm.
Okay, so after discussing this, now let's move to the concept of transfer learning. And there is a file, transfer learning and fine tuning, that I'm opening. So let's see. The other part will be covering in our next session. And let me give you an overview of this transfer learning concept. Okay, so we'll be applying transfer learning on a data set which is the dogs and cats data set, and we'll be using a part of this data set, and we'll be using one trained architecture mobile net v2 that has been trained on ImageNet data set. Okay, so here we need some package for some visualization, that is TQDM, and we can download this particular data set from this particular link which is available this, and it will uh, download this particular data set in our in my current working directory. Okay, it is already there. Okay, and then we'll be doing some sort of pre-processing. So since we have downloaded the zipped file, so the zipped file need to be unzipped uh, by our program only. We do not need it. Okay, so we have imported some of the packages. We have imported OS. We have imported zip file for zipping and unzipping the files that can be used. We have imported this NumPy. We are using TensorFlow, and inside TensorFlow there is Keras, or you can directly use Keras. You can import Keras directly, or you can import it as the part of TensorFlow. We'll be doing some sort of plotting. So we have used this PyPlot. TQDM is doing for some sort of the plot level processing, and then we are importing this image data generator. So that we did directly from keras.preprocessing.image. And since keras is also the part of this TensorFlow and it works as a wrapper for TensorFlow, so you can import it that way also. And after importing these packages, what we are doing, we are just unzipping our this particular GIF folder. So our current working directory, it has been downloaded, and the file exists with cats and dogs filtered.zip. So this is the path of our directory, and we'll be just using extract all function for unzipping it. Okay. Okay, it will do the extraction, and then we are closing this zip. So you do not need to have this, these steps. If you have a folder, you can just download it offline and can upload it directly on the system, and then you can read, that data set in the way that we just discussed in the previous example. And we are just setting up the path of the data set. And here we are having two directories. In train directory, our this training data set will be available, and inside validation directory, our validation data set will be available. So we are just defining paths for them, and then we are building our model. So this is the part of the transfer learning and fine tuning. So what is basically the transfer learning concept? That we are having already pre-trained architectures, and those pre-trained architectures have been trained on large data sets by some of the companies. Like there is an architecture called as Inception that Google has trained. There are certain architectures trained by Facebook, certain architectures trained by various other companies, by IBM and others, Microsoft. So what they have done, they have used tens of GPUs in parallel, and they have trained their models on the large data sets. So this particular the pre-trained architecture that we are using today is MobileNet V2, that has been trained on ImageNet, and it may take even a few days or weeks if you train that on your on your own. So we can take advantage of this available architectures or resources, and we can solve our own problems by utilizing their weights which are available in the form of trained architectures. So what we are doing here, we are just defining an image shape. So we'll be working on image sizes of 128 and 128 and 3. And every architecture supports some given image types only. Like for this ImageNet V2, it supports 96 by 96, and I think 128 by 128, and 256 by 256. So if you are using any pre-trained architecture, then you need to Google it, that what should be the image size for that, and you'll find the doc string and the documentation for each type of pre-existing architectures. Like for ResNet 50, it is different. For VGG 16, it is different. For VGG 19, it is different. For this MobileNet V2, it may be different. So just need to Google that. So we'll be providing the images in the size of 128 by 128 and 3 channel. And what we are doing, we are loading this model. So we are not defining any architecture of our own. We have a pre-trained model that has been trained on this ImageNet data set, which is the largest object category data set. It has, I think, thousands of categories of the objects, and the millions of images are there in this particular data set. So that is a very, very, large data set. And we are loading this particular trained model. So this is our base model. So since its output, the final output that it would be given would be, the 1,000 neurons in the last layer, because there are 1,000 categories of the images. But we want to customize it. We want to customize it to work with our problem. And the problem that we are going to solve with this MobileNet V2 is to classify dogs and cats. And you can use it even for your, own problems. And why we can use transfer learning, because as I told you that any deep learning model is an end-to-end architecture. So in end-to-end architecture, you do not have to bother about the feature extraction. The model is extracting features and learning from the data itself. But if we talk about other traditional approaches like SVM and others, then you need to do the feature extraction on your own. And working with images with simple SVM is very difficult. You need to do the feature extraction, and then only you can feed your data. But here, the feature extraction will be done automatically, and that learning is saved in the form of weights at different layers. So maybe the first layer is doing edge detection, then the second layer is detecting different shapes, the rectangles, ovals, lines. And then the further layers may try to recognize other advanced level features, like for animal classification. They may detect the furs, they may detect the eyes, they may detect the noses and forehead, and various other parts in the image. So that feature information is already available in the form of weights with the model. And most of the objects have those features. And these pre-trained architecture can help us a lot. So we'll be discussing, continuing from this point. I think there is a time for break, and I do not want to overrun between these two sessions. So we have further session that will continue.
Yes, sir. We can break now.
Okay, so after 15 minutes, we'll be resuming back. At is the break of 15 minutes now?
Yes, sir. Yes, sir.
Okay.
Hello, sir.
Yes, yes, please. Please go ahead.
Sorry, it's Prashant. Again, I was having a doubt.
Yeah.
Sir, we discussed about the binary classifier till now, and in the program also we discussed about that code binary classifier. And my question is, suppose the problem what we discussed, the boy and the girl.
Uh-huh.
Now, suppose in a single frame, multiple objects will be there. Then
Yes,
we will
yes.
go. Then we
So
will go for multi-class classification.
yes, yes, multi-class. So what you need to do, you just need to change, two things. Uh, One is the optimizer. So for binary classification, we use binary cross entropy. And if you are having multiple classes which are categorical, then you just need to change this categorical binary cross categorical cross entropy. If those are numbers, if those you want those levels to be numbers, then you can just change it is sparse categorical cross entropy. So
Sir,
not much has
uh,
to be changed.
okay,
Only you just need to do one or two lines of changes in optimization and that, and
okay,
it can work perfectly with that.
okay. Sir, I am having issue with the data set. Like
Okay.
in the binary classifier, from the beginning, what we discussed, we take the example, we go for download extension, all those things. and we store the data in different files, or in a particular file we store all the images.
No,
And
no. There is just a folder. So that will
uh,
be the folder for your data set. And
uh,
suppose you are having 100 classes of the objects. So you need
okay.
to create just 100 folders.
So
And the
that was
system will,
my question. Suppose
yeah.
in a single image, multiple objects will be there. Now, do I need to go for a single folder or different folders? Suppose in a particular image, suppose a boy is there, a girl is there, one cat is there, one dog is there in a single image.
Okay. So
Then
for
how to
that,
extract the data and how to store individual images in different folders? That was my doubt from since that time.
okay. So for that, there is a multi-level classification problem. You can go and search for that, and it can be, achieved in both the ways. Whether you want to have the multiple levels for an image, or you are having different, categories of the images, and then what you can do a kind of ROI search. So ROI search is just region of interest. You'll be taking one window and will be uh, just uh, just swapping it across the image, and will be finding it that what exists there. So most of the traditional algorithms work like that. Like if we have OpenCV and we have already trained classifier, so what we can do, we have one detection window, so that is moving across the entire image and detecting that what are the different categories of the people there, or different types of objects are there.
Okay, sir. Okay, sir. Thank you.
So you can work on ROI level, region of interest,
Excuse me, sir.
and it will be there for drawing the bounding boxes for those images as well. It can be used. It can detect that where a particular object exists, and what is the bounding rectangle for that.
Okay, okay, sir. Thank you, sir.
Okay.
Excuse me, sir.
Yes, yes, please.
Good morning, sir. Sir, I have posted a question on the chat box regarding image filtering and sharpening. Uh, just please see the. Sir, are you able to see the question, sir?
Uh, just a moment. Let me just scroll it down.
Sir, I will tell, sir. Otherwise, when we should go for the image filtering and the sharpening techniques, sir, before training, when that means in the pre-processing phase. So when we
Okay.
should go for them.
Basically, sharpening and this is not required. It may be required if you need it separately. Like if you want to go for super resolution images, or if you want to increase the crispness of the image. It may be required as an application requirement. But when we talk about means creating variation in our data set, so we do not want our system to overfit. So what we'll do, we'll take images and we'll try to create variations on those images. We are just tilting it, we are just doing a kind of shifting so that objects locations change, and then we feed it to the system so that it learns a generalized structure for that. But if you want to use it as an application, then that can be done with various image processing techniques, and you can even use the deep learning, like the auto encoders we can use for those modifications, and we can stitch back the images, and even we can use remove the watermarks from the images as an application of this auto encoders. So that can be done, but it is not required to change it as at the pixel level. We just need to create a variation in the image, in the form of shifting it, in the form of zooming it, in the form of cropping it. So these are some of the basic operations, and that is just for the data augmentation. So data augmentation means we are having some existing data, we are just augmenting or extending it.
Extending, yes, sir. Sir, one more thing, sir. Sir,
Yes.
instead of doing something on the collab, that means you have some research
One second, Mr. Jagadish. I
yes, sir.
request
Yes.
you to keep your question for the next session. Let us give some break for the
Okay, okay.
sir so that he can just relax for 10 minutes and then come back.
Okay. So Jagdish will
Sure, sir.
continue from your question in the next session.
Yeah, thank you, sir. So the participants be on the meeting itself and the YouTube also, the same link will be streaming for some time. So patiently be available in the meeting itself. And I would like to make some announcements to the participants. Once the session is over, we'll be having a lunch break and we'll resume the meeting by 2:30 sharply. I request the participants to be available in the meeting by 2:20 itself, and we start the valedictory function at 2:30. And after the valedictory function, we'll be having the test, a multiple choice question test, and the link will be provided to you during the lunch break. And the test is designed in Microsoft Forms. You can directly open that link in the browser and can take the test. And there will be 30 questions and you'll be given 30 minutes of time to finish your test. And as and when you finish your test, you can view your score. And remember that you need to score 60% minimum to get the certificate from the AICT. Thank you.
Hello everyone, I'm back. Can we start?
Yes, sir, please.
Okay, so what was your question, Jagdish? What were you asking? Okay, if there is no question, we can take it later on. So, as I told you, that transfer learning is just to utilize the power of some pre-trained deep learning architectures. There are many deep learning, pre-trained deep learning architectures. So as far as this task of image classification or object recognition is concerned, we have this MobileNet V2 architecture, which was trained on ImageNet. And we are just loading this particular model and creating a variable with name base underscore model. So this is our model that we have, which is available as part of this applications package in Keras. So, okay. So it is downloading that model. And what we are doing, we can do fine tuning. It means we can allow the changes to happen in the weights that are already learned, or we can just utilize the pre-trained weights. So for that, inside base model, the model that we have downloaded, there is a trainable attribute and we are keeping it as false. It means uh, we do not want any changes in the weights, but definitely we'll be unfreezing some of the layers and we'll be doing some changes there, and that is the part of fine tuning. Now what we are doing, we are defining a custom head, because if you talk about the last layer of MobileNet V2, so that contains 1,000 neurons. It means to classify the objects into 1,000 categories. And but here, because we are working on a binary classification problem, so that's why we need to keep our the head of the model, that is the output layer, to be custom according to our application. So here we can see that what is the output or what is the final layer of this particular model. So it is of this particular shape 4 into 4 into 1280. And what we are doing, we are just applying a global average uh, pooling for that, and then we will have the customization on that, and we'll be just adding one dense layer, and that will be having units as one, because for binary classification, one neuron can predict it. And the global average pooling is just the variant of max pooling. Okay, so this is the final linear output of 1280, and then we are adding one prediction layer on the top of our base network. So here, whatever is coming as part of this global average layer, we are taking it as the input to our this custom layer, and that is prediction layer. So this prediction layer is having just one neuron and the activation is sigmoid. So we are doing it, and then we are just defining a model based on our the base model will be acting as input, and this prediction layer will be acting as the output. So we are combining the base as well as our custom head, and will create a model out of that. So for that we are using this model API or functional API provided with the Keras. So here input is this and output is this, and it is creating a new model. And after combining MobileNet v2 and our own custom head, we can see that what is the architecture of our model. So the model of summary can give us, the idea that how many layers are there and what type of architecture is there. So this is the architecture of our custom, network. Okay, and then what we can do, we can just compile it. So for compilation, we are using optimizer as RMS prop. Loss is binary cross entropy, because here we are dealing with binary classification. But if you are working on multi-class classification, like instead of just having, the two classes, you are having multiple classes, then here the loss will change according to that. So if you are having categorical classes, then you can have categorical cross entropy. If the classes are in the form of some numeric values, or you want the network to train based on those numeric values, then you can go with sparse cross entropy. And so here the matrix is accuracy. So this particular step is quite uh, familiarized with your learning. And the optimizer is RMS prop. You can just use the string optimizer equals to and single quotes RMS prop, but here we want learning rate to be customized. So for that we are calling this function, which is available in keras and optimizers and RMS prop, and here the learning rate is 10 raised to power minus 4. And that is the most effective learning rate for image classification. So we are doing that. Now we are creating the data generators. So we have already downloaded our data set, which is available in the cats and dogs directory. Okay, so the compilation is done, and then the data generators for training and testing in the same way that we did. And here what augmentation we are applying, we are just rescaling the images to 0 and 1. So every pixel will be divided with 255, so that whatever data we pass to the classifier, that is in the range of 0 and 1. As I told you that neural networks work best with the with the small values. And for that we are rescaling our data so that it is in the form in the range of 0 to 1. And train generator, so from uh, this particular directory that we have already defined, train underscore directory. So the target size, the image size should be 128 by 128, and they'll be coming in the batches of 128. So in earlier example, our own classifier, we kept it as 20, and the size of the images was 150 and 150. And here the class mode is binary, because we are just having two classes, and it will automatically detect that how many images are there. So there are 2000 images, and they are belonging to two classes, dogs and cats. But the original data set contains more images. I think 70,000 or 60,000 images are there in dogs and cats data set. But this particular data set is uh, just a sampled out version of that, and we are dealing with 2000 images. So this is a train data generator, and 1000 images are belonging to this validation data set, and there are two different folders there. And then we can just use this fit generator function for 5 epochs. And instead and along with the training accuracy, now we'll also be getting the validation accuracy, because we have validation data set available with us. So it will be performing some training, and that is called the transfer learning. We are not defining any model architecture. The predefined model architecture, which is MobileNet v2, which has, I think, 150 layers in total. And that is a very complex architecture. We have pre-trained weights. And what here we are doing, we are just utilizing those weights. So here you can see that the training is very fast, because we are just uh, having some customization in the head of the network. So head is just the final output layer. So there we are just doing the customization, and rest of the things are not going to be changed. So the training is very fast. Otherwise it will take weeks or days to train that particular model on ImageNet, which is very large data set, and hundreds of parallel GPUs would have been used to train this model. And here you can see that with this task, we are getting the training accuracy 100% just after the third epoch, and the validation accuracy is very impressive. So in the first epoch itself, we got 94.9%, and then it is continuously improving and ending at 97%. So it is quite interesting, and it is coming out, from the already pre-trained weights or the power of the network that we are having. And further you can unfreeze some of the layers of this network, can allow some of the training to happen at some of the layers. And when we allow the weights to change, when we allow the hyperparameters to change and update, so that is called fine tuning. So if you do not get some accuracy here, and you want to have some custom layers, you want to change the network architecture based on your custom data, then you can go with the fine tuning. So fine tuning is an interesting step, and that can work. So I'll tell you that when to use, when to train the model from the scratch, when to do fine tuning, and when to do just the transfer learning. So there is some heuristic available on that when should we perform transfer learning, and when should we just go with this transfer learning, and when should we train our model from the scratch. So here you can see that the validation accuracy and all that. So this is, we are evaluating our model to get the accuracy printed. So it is 97. And now let's move to another interesting concept, and that is fine tuning, that how we can fine tune our network. So as you know that there are there are total 155 layers in our network that we have created based on MobileNet v2. So what we are going to do here, that we want to unfreeze some of the layers. So in some of the layers, there will be changes in the weights or the learning parameters which are there based on our this this custom data set. And since we are getting here a very impressive accuracy, the training accuracy is 1, or it is representing 100, and the validation accuracy is also very good. And it is not always true that if you do fine tuning, then you will get the better results. So you need to look at the size and the nature of your data, and based on that you can do some sort of hit and trial, and then can do some changes to happen based on that. So what is fine tuning? That you can unfreeze some of the part of your network, and can allow the weights to get updated when the model is performing training. So for that, what we have done, initially we made this trainable parameter as false, but here we are now making it trainable for all the layers. So base model dot trainable, and we are keeping it true. So it will be trainable. And what we are doing, that will be freezing some of the layers, and will be unfreezing some of the layers manually. So we'll be doing this manually, and we'll be doing fine tuning at level this 100, and from starting till 100, means layer 1 to 100 will be making trainability as false. So what we have done, we have just we are just running a simple loop. Layer is just the variable, and it will go till here. So base model dot layers, you will get all the layers here, and the colon and fine tune at. So the starting is from the beginning of this layers, starting from the first layer, and it will go till this the 100th layer, and after 100 layer it will keep the things true. So what we are making from 1 to maybe 99, we are just keeping it as false. So the starting 100 layers will be freezed, and rest of the layers will allow the updation of the weights. And once it is done, okay, then we are recompiling our architecture. So whatever model we defined, we are just recompiling that. So this is our new model, which will allow the fine tuning. So what is fine tuning? That based on the custom data, the model is updating its weights. And once that is done, then we'll perform again the training. And here you can see that there is changes, there are updations happening. So I have already trained it some other time, so that training snapshot is available there, because it will take some time, because weights would be updating. So now you can see that the validation accuracy and how this training accuracy is turning out to be. So the validation, the training accuracy is reaching 100%, but the validation accuracy is less than the earlier accuracy that you got from just transfer learning, because it is 95.9, and earlier with this with just transfer learning it was 97 point something. So here you can see that the transfer learning is not doing much improvement, and there is a heuristic that has come out of the various experiments performed by people. So that is just a notion, that is not the exact kind of some deterministic statements, that when we should train our model from the scratch, when we should do fine tuning, and when we should do transfer learning. So there are 4 points in this regard. So if we have large and different data set, it means we are having a very large, and there are variations in the data sets. So we should train our whole model from the scratch, because in that case transfer learning cannot or this fine tuning cannot work well. So if we are having different data set, totally different, because we should just look into that what are the 1,000 categories, and whether uh, do our the model classes, the classes that we are training the model on, has some resemblance with the pre-existing classes on which some pre-trained architecture was trained. So if the data set, current data set is large, and it is a different data set altogether, then we should train the whole model from the scratch. And if we have large and similar data set, it means the data set that we are having is also large, and it is similar to the classes of pre-trained model, then we should go with fine tuning, because these classes, the cats and dogs that we are having, those are very much similar to the classes of ImageNet data set. But if we have a small and different data set, then also we should go with fine tuning, because here the data set was just just 2000, so we applied fine tuning. And even if it is different data set, like you are just figuring out the difference of something, whether it is rainbow, or it is something like different, which is not the part of the pre-existing data set on which training was done. So still you can go with fine tuning with a small and different data set. And if we have a small and similar data set, then we can do transfer learning. So fine tuning is required only in two cases: when we have large and similar data set, and when we have a small and different data set. So the fine tuning can work, well. But if you have a small and similar data set, we can just go with transfer learning, and the fine tuning may not, work well. And for large and different data set, if we have availability of that, then we can train our model from the scratch. So here is the final accuracy for that, which is 95.89 or something coming out, like that. So any question here related to transfer learning and fine tuning?
Sir,
Yes, please.
sir, actually, I missed the past 5 to 10 minutes session. So kindly, please brief what is transfer learning. Only brief the concept.
Okay, the concept of transfer learning.
Yes, sir.
Okay, so transfer learning is basically to use your pre-existing knowledge. Suppose if you know how to ride a bicycle, so there is some learning coming out of that, and you just want to learn that how to ride a scooty or gearless scooter.
Okay.
So these two problems are different,
Yes,
but there
different.
is some sort of similarity.
Yeah, riding.
It means riding that how to keep balance on two wheels and
Yes,
something
yes,
like that.
yes, sir.
So and it is also a kind of pre-existing notion that the people who already know how to ride the bicycle can easily learn how to ride the scooty. But
Okay.
if there is a person who is trying to learn scooty first time and does not have any experience with riding bicycle, then it will be a challenging task for that person. So the
Okay.
transfer learning is just like that we are having some learning already stored. So how the learning is stored? So when we train any neural network, तो उसकी जो learning जो store होती है, that is in the form of weights and biases,
Yes,
or that
yes,
we call as parameters or trainable parameters that we get as the summary of the result.
yes,
So if there is some person who knows the cycles, then he knows various things. He is understanding that if I tilt the handle to the left, so it will rotate the bicycle to the left. If I keep it to the right, it will rotate the bicycle to the right. How can I apply the brakes? And if the speed is very slow, then there are
hmm,
chances of being collapsed. If it is
hmm,
moderate, then bicycle will move forward. If speed is very fast, then there is a chances of the being collapsed. So these
yes,
are some of the learning parameters which are stored in one's memory or in one's subconscious mind. Now
yes,
there
yes,
is a new problem of how to ride the scooty. So automatically some of the things that he has already learned will help him. That
yes,
how to apply brakes. If I tilt the handle to the left, then it will move left. If I tilt it to the right, then it will move right. I need to look forward. My eyesight should be forward, and my hand should be uh, on the handle. So in the same way, transfer learning works. So we have
okay,
already some pre-trained models, like we have this MobileNet V2 architecture. In the same way, there are other pre-trained architectures that have been trained by tech giants. So some of the architectures have been trained by Google, by Facebook, by Microsoft, and with other companies. So they have invested huge resources, they've invested long hours, and they have come up with some strong architectures, and their weights
okay,
and biases are available that we can utilize for doing our custom tasks. So here what we are doing, we are already having a pre-trained model in the form of MobileNet V2, architecture that we are loading in our model. We are changing the head of the model because this MobileNet V2 architecture was trained on ImageNet dataset, and ImageNet dataset has 1,000 layers. The 1,000 classes of the different objects. तो इसकी जो last layer थी, that last layer contains 1,000 neurons, but we want a
Okay.
custom task, and the custom task is to classify dogs and cats. So, and we want that learning to work on our this custom task. So for that we'll be using the weights or the parameters of the pre-trained model to solve this particular problem. So for that we are using this transfer learning. So what we did, we just took the base model, we just deleted the last layer from the model, we added our custom layer, the output layer on that, and we combined both of these parts with the instance of model class, by which we can create a custom network. And then we made the trainable. It means we can also unfreeze the layers, but we just fixed it that we will not learn anything new, and we, based on our previous learning, we will try to solve this particular task. So for that we kept our all the layers freezed, and for freezing that is very simple. So in base model and dot trainable is the parameter, you just need to keep it false, so the model will get freezed, and then you can perform training on the custom model. So custom model is our custom head and the base of MobileNet V2, and then we are seeing the summary of that. So 155 layers would be there in this model, and then we are compiling it and then just checking its accuracy. So here we can see that accuracy that we got 100% accuracy on training data, and 97% accuracy on the testing data. Now we can further play around with this transfer learning, and we can allow some of the layers to update, or we can allow some of the weights to update at some of the layers. So that is called fine tuning. So what is there? Suppose you already know the scooty, or suppose you already know that how to drive the car, but the car that you are driving is Wagoner, and suddenly you have to drive the Audi, and that is automatic.
Yes, sir.
So for that you have drove the Wagoner for suppose 10 years, and then you are made to sit on the driving seat of Audi. So what will you do? Most of the functions will work in the same way, but some of the functions you need to understand, like what are the different sensors, how the vehicle is responding to the different inputs. So that is called fine tuning. So you are the best driver because you have drove the car for 10 years, you are experienced enough, but you need to learn some of the things. So the learning of driving is already in your mind, but you need to update some of the things as per the new requirement. So that we can do with the fine tuning. So fine tuning के लिए what we do, we unfreeze some of the layers. So some of the layers, suppose एक layer आपके brain में है कि how to shift the gears, but it is gearless, and there is a layer where there is an understanding that how to use clutch, but there is no clutch in the in Audi because it is gearless.
Automatic.
So what you need to do, you need to update some of the learning that you are already having, and some of the layers need to be updated. So for that, we can unfreeze all the layers and can then manually freeze the starting layers, and then allow some of the layers to update. So for that, we did this fine tuning. Initially, we freeze the model, and then manually first we unfreeze the entire model, and then we freeze some of the starting layers by keeping the trainable as false, and then training our new model. But this time uh, in last I told you the four instances that when to use fine tuning, when to use transfer learning, and when to train the model from the scratch. So this fine tuning did not work for us in this particular case. But this is just the gist of what we discussed.
Okay.
Okay, so now let's move towards the next part in this session, and that is very interesting. That is called auto ML. It means that there are people, because the IT has been used for automating the things. So starting from any industry, if you talk about any industry, IT is there, and IT does not have its own standalone existence. As an industry, IT cannot survive if it cannot provide support to rest of the industries. So this is just a kind of jack, and IT is enabler. It is not abler. It will not make you to do anything independently, but it can help you in doing some all of the things that you're doing. So in the same way that earlier the automation has been in various industries. If you talk about factories, so there are automations coming up, the machinery automated various manual processes, and now everything is being automated. And even the people are thinking of automating this entire data science, machine learning, and analytics job. So today there are huge jobs available in industry. So IT, you may say it as the some people may find at the challenge or kind of threat that IT is posing, that it is automating everything. So today we need data scientists. Today most of the work is being done manually. We are creating models.
Yeah.
We are Okay, so we are testing it manually, but there are people. There are just the recent advancement in just last 1 or 2 years, that people are using automation at the machine learning. And there is a concept coming up, that is automated machine learning. And there are a couple of libraries which are existing there, that instead of you create the model and then manually test it, that which architecture is best for you, and how it can be used, you can use some built-in functionalities, built-in libraries. They will create the model and they will look for the best performing models for you, and that model you can save, and then you can utilize it for the other purposes. So isn't it interesting that instead of creating architectures on your own, you are letting some program or some mechanism to create architectures on its own, and it should test 15, 20, or how many architectures you want. It will create different mutants of those architectures, and then we'll try to test that which are the best performing models and which is the best. And it will give you that particular model, that this is your data. Instead of using this model, this is the best model which is giving you the best accuracy out of the 15 or different models which were tested. So that is called AutoML. So there are different libraries for AutoML, and today we are going to discuss, since this is our deep learning session. So we'll be talking about a library called as AutoKeras. So this AutoKeras is not by default available with your Google Colab. You need to install it, and at the back end of AutoKeras, there is another library which is Keras Tuner. So both of these packages, both of these libraries should be installed on your system. And as the first line, I am installing this AutoKeras. So since it is already installed, and it is for its size is of for a few MB, I think 60 or 70 MB. So it is a huge library, and it will take some time if you install it. And if you're working on any Jupyter environment, whether you this Google Colab or some other tools which are supporting this IPyNB format, if you want to install any package, so you can write the command. Like here we are using pip, which is the package manager, and just place this sign of exclamation before that particular command. So it will run that command and will try to install that package in your online environment. And the AutoKeras is installed, and then we can see that whether it is actually installed. So there is a pip show command, so it is telling you everything about this AutoML. So AutoKeras is just the implementation of AutoML for deep learning. So its version, who created it, and author's email ID. So everything you are coming to know. And then for this AutoKeras to work, we need to have this particular package, which is Keras Tuner. So it can be installed with this Keras and Dash Tuner, but it did not work for me. But because it was by default installing Keras Tuner version 1, but we need this particular version 1.2.2. So I manually took it from this Git repository, and it is this the latest version. So I need to install it. Okay, since it is already installed, so it won't take much time. And now what we are doing, we'll be just learning that instead of creating our own deep learning architectures, can we automate this task that deep learning architecture is created automatically, and various variants that we call as the mutants are available there in the form of models, and those models are being tested on some data, and the accuracies are being taken into account, and then the best performing model uh, uh, is reported to us. We can save it and we can work on that. So that is the whole idea of this AutoML concept. And today we'll be using a very simple data set, which is a kind of legacy data set, which is Sonar Data Set. So it is a numerical data set, or kind of tabular data set, which is having this description. So there are just 208 rows in the data set, and there are 60 input features. Means there will be 60 columns for which the values will be there. So there is a huge number of columns, and there will be just two classes. The classes will be either whatever signal we are getting out of these 60 features, whether that signal belongs to rock or that signal belongs to mine, whether that sonar data set is being returned back after hitting to a rock, or it is coming from a mine. So the data set is like this. This is just for the sake of understanding and to learn that how AutoML can work. So we are just importing some of the packages, NumPy as array. So we are just renaming pandas. From pandas, we are importing this read underscore CSV, because the data set is available in our CSV file. And for model selection, so we'll be dividing training and testing data sets out of this data set. So we are importing this sub package train underscore test split and label encoder. So we'll be encoding our labels based on that in the form of zeros and ones. So, and then AutoKeras, we are importing this structured data classifier. So this particular function is very, very powerful, and this is the magic behind this AutoKeras. It will create different mutants, as many mutants as you want. It will test the working of those mutant models, and it will report the best possible model to you. Then we are loading this Sonar data set. So this is from the GitHub repository of uh, Jay Brownie, who is the creator of Machine Learning Mastery website, and I have taken this code from there. And this you can find from you can download this particular data set from this UCI machine learning repository, because this is a very, very popular data set. And what next it is doing, URL is the link for the data set, and the data frame that we are reading, we are using this pandas function, which is read underscore CSV, and it is reading from this URL. and we are not keeping any header. So it means the first row will belong to the data itself, and there will be 60 values, comma separated values in our data set, and those are representing the different features. So we can print here the shape of the data set, that how many rows and columns are there. And here you can see that the dog string is just printing that it is 208, and then the 61 columns, and the last column is representing our class, and there are 60 features. So next we'll be extracting the features, will be separating features and the classes. So for that, since this data frame is there and our model can work, deep learning model or any model can take three types of data. Either it should be numpy array, or it should be the built-in data object, or it should be data generator. So we cannot directly perform training on the data frame. There are two types of data structures available with pandas: the data frame and series. So data frames are the higher dimensional, you know, the just like the tables. And what we are doing, we are just converting this data frame into values. So this will be converted into numpy arrays, and that we can use for our training. So we are splitting this feature and class levels. I think this you would have got an idea in previous sessions by taken by other experts, those who have given you a basic idea of this, that how uh, uh, this division can be performed. So from the data, uh, we are extracting this the features and the class levels, and we can figure out that what is the shape of them. So this is something which is repetitive, and then we are encoding our classes into the binary representations, zeros and ones. So those are in the form of some categorical values like rows and rock and mine. And what you are doing, you are now splitting this particular data set. So 33% of the data you'll be using for testing, and 67% of the data you'll be using for training. So that is how this split is done. We have X and Y's for training, and we have X and Y's for testing. And then we are printing their shapes, that how they're doing. Now the most magical step is this one, which is the crux of this session, that we are defining a search, and that search is being defined by with structured data classifier. So what this structured data classifier will do, it will have maximum 15 trials, and 15 mutants of one network architecture would be created, and you do not have to define that. So it will be automatically a network architecture would be created, and then the 15 different network architectures will be evaluated in different 15 trials. So this is just like that. So this is a kind of evolutionary approach, just like hill climbing, or you are trying to find the minima or maxima. For that, as we do in the the evolutionary algorithms. So it works like that, because it is searching for the best and the fittest solutions that can solve your problem. So uh, there is a paper behind this. There are some mathematical things done behind this. Many people have come up with its variants, but it has been done in last 1 or 2 years. So it is something which is very recent, and you just created a search, and then on search you are just fitting your data. So there is training happening with this fit function, and it will show that how the training is happening. Then you can come up with the evaluation, that how it is performing on the test data, and you can print its accuracy, and then you can even test it for one sample. So here you just need to provide one numpy array. It is just a list, and that needs to be converted in the form of numpy array, because the numpy arrays are the is something that you can pass for prediction. So these are the 60 different values that you are passing for prediction, and you are just trying to find out that whether it was it was what was the prediction for this for the different search, the different architectures of the model that you are dealing with, and then you just need to get the best model. So the best model will automatically get saved to this, and that you can export. It means instead of defining your model on your own, so this will be a neural network model. What you are doing, you are just calling this function export model, and the best model that has come out of this search result, that will be saved here. And then you can see that what is the summary of the best model, and then you can save it in any extension that you want. So this is what is happening in this this entire code, and this is how it is the printing the things. It is doing the searching, so it is taking its time in training. It is working on 15 different models. And generally, since this particular data set is very hard to train the model, because there are 60 different columns and there are just 208 rows, so it is very difficult to get any accuracy which is more than 40% or 30%. But still, our the best model that we are getting is this one, and it is giving the accuracy of 68%, and this happens to be the architecture of best model uh, that we have found out of this. So this is just a kind of, this entire field is under development, and this is called neural architecture search paradigm, NAS. So people are working on this particular field. And yeah, so if you have anything to ask on this, that how we can do auto ML and how it can work.
Sir, I want to know ask one question.
Yeah.
How do you know which model is good with this search auto ML? Because it's searching and finding a suitable model. How do you find which
Yes.
model you choose?
Okay, so what it is doing, it is creating, in this case, 15 different mutants of architecture. It means there are 15 different models. It is doing training on that, and it will just discard the model. We can further customize it if the model is taking more time in performing training or doing some sort of thing on that. So everything happens behind the scene. But as per the accuracy is concerned, because it is, we are training the model, and it will uh, try to assess the accuracy on 15 different architectures, and whichever architecture gives you the best result, so that it will save as the last model, and it will just discard others. So it is just like that. There is an array, and we just want to find out the maximum element of the array. So how we can move ahead? We just assume the first element as the biggest element, and then keep on comparing it with rest of the elements. So we take a variable max, and we initialize it with the first variable, and then we compare it with rest of the variables, and whatever bigger value we have, we update it. And at the last, what we are left with, we are left with the best model or the best architecture or the maximum element. So it is just doing that, and taking accuracy as the parameter uh, to test the fitness of the models, that which model is good and which is not good.
Sir, can you come share this program with us, with this auto ML program?
Share. So I'll be sharing this. Yeah, definitely. So I'll be sharing this entire folder with you, where you'll get. Okay, so let me just. Okay, so just click here and you can download everything which is available in this folder. and you can take this learning, forward. So some of the things we might not have time to discuss, but that is available. Some of the examples related to text processing and how we can use this deep learning for various other stuff. So, but that's it related to this auto ML. This is just a kind of introductory kind of thing, and then this particular thing is also in inception, because people are exploring whether we can automate this task of even machine learning, or finding out the best models, or performing the training. So everything will be automated. You are loading the data, you are performing the search for the model, and there are various algorithms for doing this. So it is just a kind of grid search way. You can find out the best solutions. You can find out the solutions with evolutionary approaches, like for finding the just a hill climbing algorithm, where you just need to find the global maxima and how you can proceed further. So GAs can be used, the genetic algorithms for evolutionary, for finding out the precise solution. So people are working there, and it will get cleared whether this hype of data science lasts for next 5 or 10 years, whether the people are able to automate this task as well. And then there are new challenges coming up in this particular field. So yeah, you can do this. And okay, the next thing that I just want to give you an overview, that is the how to use these deep learning models on your mobile devices, and how that can be performed. So for that, there is a totally different library or kind of variant of TensorFlow, and that is called TensorFlow Lite. So TensorFlow Lite can be used for for using your deep learning models in some device, and you can utilize it. So let's just have something to know about the TensorFlow Lite.
Sorry to interrupt you, sir, but we are not
Yeah.
able to access the drive, please. Just look into it, sir. The drive needs access. Is actually asking us for permission.
Okay. Just a moment. Let me just. Okay, so just try to refresh that. Try to access that. Is the same link working?
Yes, sir. Yes, sir, is working now.
Okay. So you just downloaded this entire folder. It is also containing the data set that we discussed, and various other resources.
Sir, thank you for your sharing. Sir, I have one doubt. Can we include our own model to compare with this one, AutoML?
To
With this,
compare with this
our own
one,
model. Yes.
so, that you need to, I think, do the manually, because
Yes.
whatever magic is happening here is due to this particular, this particular code that is
Okay.
coming out from this search, this structured data classifier. So it is automatically doing this, and that is the beauty of this, auto.
आवाज आ
So
रही आवाज आ
hello. So
Yes,
something
sir.
which is auto, that may not need the some manual intervention. So I don't think that any manual intervention is possible to inject your own code to this. but you can just look its documentation if some sort of customization is available with this in the form of callbacks or something like that. So you need to explore that, because I have not done that thing yet. I'm still exploring this. But what you can do, suppose you are getting one model out of this, then you create your own model, and then you can manually compare that what was the accuracy of the model that you are getting, and now what is the accuracy of the model that you have created, or the best model that you are getting here after this, after the completion of this search. So what you can do, you can apply maybe the transfer learning on this, that here you are fitting, and then you can just get this particular model, because from the summary you can see that what is the architecture of this model, and you can even save this model, and that is available with this H5 extension. So here we have saved this model with H5 extensions. Weights and everything is available to you, the layers are available to you. Now you can customize it and can see further that how it can be done. But as of now, I don't think that initialization of the model is possible, that you are creating one architecture and then it is refining and working on that. So it will create its own initial architecture and will try to refine it and try to create variants out of that. But definitely the magic and power that is coming up is from this particular structured data classifier. Is it clear?
Yes, sir. Thank you.
Okay, any other question? Okay, so if we talk about that, how to take this deep learning and this machine learning task to our mobile devices, then once you perform the training here, then you can save the models with different extensions. The H5 is very popular extension, and we can save it in with JSON format. We can save it with pickle format, and there are various other formats available for saving our the model and the weights that we want to use later on. And here in the in the sequence of saving models and exporting models, there is a simple concept that whether we can optimize it for mobile devices. So that is just a kind of compression, that is just a kind of mechanism which will make your model portable so that it can be loaded or it can work with mobile devices as well. As you see that even the mobile devices are coming up with with very high end computational powers, and the difference between a mobile and laptop is becoming very thin. So you are having mobile phones having 16 and 16 GB of RAM, and the processors are the quad cores and others. So those are very comparable with the laptop devices. So something that you can run on laptops or personal computers, desktops, that can also run seamlessly on your mobiles. But you can definitely optimize the exporting of the model as per the requirements of the mobile devices. And for that we have a library called as TF Lite. So there is TensorFlow Lite, and how you can export any model. So you just need to have, it is the part of TensorFlow, and we are already having some model, and that model can be, we need to create a converter, and that converter can be used for saving our model. So there is TF, and then there is Lite package, and then there is TF Lite converter that we are creating. So there is a doc string that tells that it converts a TensorFlow model into TensorFlow Lite model. So there are different attributes related to this. So you can just go through and can explore it, and it can save it in a format that is suitable for this to be imported in mobile devices. So this is an interesting library, and it has various use cases. You can create apps that can work with deep learning, and this is the entire the website dedicated to this, which is the part of TensorFlow, and there is a light version for that. And you will find various examples, various use cases, that how the trained models can be used for that. So you need to explore it. First you need to have some basic understanding of some like how to create basic iOS applications and Android applications, and then you just need to export it in the form of light version with the help of TensorFlow Lite, and you need to just create a converter from there, and that particular model can be imported with Android. So now some part comes to this to this conversion, that how the conversion is to be done. So there is just one or two lines of code that is very simple, but the major part comes the Android application development, and then using the API of Android or iOS for using those models. So if you are interested for that sort of application, some mobile based applications that can work in that way, so you can have you have a very good documentation for that. But what is TensorFlow Lite? TensorFlow Lite is an open source deep learning framework to run TensorFlow models on device. If you are new to TensorFlow, we recommend you to first explore pre-trained models. So some pre-trained models are there, and then there is a step-by-step guides that how to get started with them, and run the example apps below on a real device to see what TensorFlow Lite can do. So you can perform various types of tasks in the form of applications. There is object detection. You can use it for image processing tasks, for questioning and answering. And uh, if you're a mobile developer, then you can definitely exploit its various capabilities. Like it can be used for recognizing different flowers. So there are pre-trained models available. You can train your own model and uh, can just export it to the mobile devices, and it works seamlessly for Android as well as iOS devices. And so there are different examples. Even you can have the image classification on Raspberry Pi. So this is something which is quite interesting, that not only you can take this deep learning or machine learning capability to the mobile devices, but you can also transfer it to some mini computers. Like if you just want to create one system uh, which should act as an independent computing unit. You have created one helmet detector system, or kind of this mask detection system. The people are going, and you are just capturing whether there is anyone who is not wearing helmet and riding the bike. So what you can do, you just take that image, you just try to figure out first that whether the riders are wearing helmet or not. And later on, if the helmet is not there, then you just save that image, and later on you can do as a next step means searching for the number plate. So in that image you look for number plate recognition part, and you just extract the number plates from that particular vehicle. And then you can automatically generate a challan which is sent that at this particular point of time your bike or vehicle just passed this particular check post, and the two people were riding, and one was not wearing helmet. Or you can just say that the helmet was not found while you were riding. So these type of applications are there, and there are many startups who are working with this, like automating this kind of surveillance in the highways. So you just you may further explore it based on your area of interest, that how it can be used. But definitely it can be the deep learning capability can be transferred to this the miniature devices, including Raspberry Pi. And so Raspberry Pi, as you know, this is just a kind of mini computer which has all the computational power. It can connect with the camera, so camera is capturing some of the images in real time. There is a model that you have dumped on this Raspberry Pi, and that particular model is doing some sort of analytics, and it is connected to the Wi-Fi and can send the uh, reports based on that. So there are many useful applications on that, and it has been uh, uh, very well mentioned and described here. So the type of application you are interested with, but this is something that you need to get started with. You need to have a little bit of Android, and we cannot discuss it now practically because we need to get started with this Android environment, and then need to explain the working of its API and then its integration. But definitely, if you have interest and you want to explore it, then you can explore it further. Whether you want to take this deep learning task to the mobile devices or to the miniature devices. So, and there are this particular documentation is very rich. You have this YouTube channel of TensorFlow where you can get updated. So this is how it can help you, like for object detection. So there is an Android and iOS example available here, and there is some metadata related to the models available here. So what is object detection? It is just like to detect different objects in the video or in a still image, and it can be integrated with mobile. So here after when this particular model will work on the device, so it is looking like that. It is able to distinguish the banana and the apple. So, and that is from the video stream. Just if you open up your camera, so it will try to sense it from whatever it is capturing from the camera. And for example, this example screen shows how two objects that have been recognized and their positions. So this leads to some multi-object classification or multi-level classification. So here you can find out the regions of interests, ROIs, and then can draw the bounding rectangles for that. So OpenCV and some other image processing and computer vision libraries can help you in doing that stuff. If you want to create the GUIs for your machine learning and others, so there are different libraries for that. So you can use them, and you can even create the GUI on Android. And this is the model output. So it is showing, it is not exactly telling you that it is Apple, but it is giving you the score. And you can get the score when there is a confusion, and there is always a possibility. And if you are interested, that you should consider the two classes and then need to manually investigate it further. So it will give you the different scores related to the different classes, that what is the possibility of apple, what is the possibility of banana, what is the possibility of strawberry. So if this difference is very close, then you can manually see it, or you can do further investigation that how to do this. But if this gap is very large, so you can be assured about that whether its prediction is good or not, and it can be done in the form of the confidence scores. Okay, so it can give you, so just explore this particular part, and whatever part of this machine learning you are interested in, you can further explore it. And there are a lot to be explored. There are new things, there are new methodologies coming up, there are new tools which are emerging. You just pick up something to get started with. Like if you are interested in computer vision, then you can use Keras, but PyTorch is one library which is very good for this computer vision tasks for image and video processing. You can use that. And now it depends on that how you utilize this learning and what type of applications and what type of solutions you come up. You can create a website, and at the back end you can run your these deep learning and machine learning models and do some sort of prediction, can combine it with uh, some RESTful APIs. You can combine it with some responses, like you are uploading some image and then you are getting some response back. And I think many companies are doing that. So if you look at the Amazon and its services, so Amazon provides you more than 170 types of services. So there are many services which are related to the AI, and it is able to do and automate the various tasks. It can analyze the contents of the images, it can analyze the contents of the videos, and it is continuously updating its training infrastructure. And you can also do that. You can utilize the power of some of the pre-existing tools. You can utilize the power of cloud. You can deploy your applications, you can make your own website. You can develop the web applications in Python. And the hybrid applications, you can have one mobile application that can be used somewhere to solve some particular problem. You can have the integration with IoT devices, like data is coming from IoT devices, it is going to some server, it is being stored there. At the back end you are doing some sort of analytics on that particular data, and some action reports or some actions are coming out of that particular data. So it all depends on how you want to utilize it. It is as per your interest. And so explore it further. Do you have any question that we may take? Yeah, am I audible?
Yes, sir, you are audible.
Okay. So we are left with 10
Sir, I have a question.
Yeah,
I
yeah,
have a
please.
question. Sir, in a transfer learning, you told us that what we need to do is we need to customize the model as per the data available to us. In that case, what we do is we take out the output layer and then we customize it for our data. So always it is happening that in transfer learning, we are only taking up the output layer and remaining layers are as it is kept freezed.
Yes, the transfer learning means that, but we can also have the customization for updation of the weights. So what is there, that we are having something which is already pre-trained, but that was the training was done on a different problem. Like for this mobile net v2 architecture, the training was done on ImageNet dataset, and
Yeah.
that was containing 1,000 object categories. So the last layer of that particular original model contains 1,000 neurons as the output. But in our custom task we just have two categories of the objects. So for two categories of the objects we can just have one neuron, and then can give and predict whether it is belonging to class A or class B. If we have three categories, then we need to have three neurons. And if we are having 10 categories of the objects,
So
then we
if
need
we have a
to
sequential data, let's say, yeah,
have.
so if we have a, let's say, sequential data, it could be in the form of paragraph in which we have words to learn, or we have got, let's say, navigations, the navigation of the web pages. So we have
Okay.
a time series sequential data. So in that
Okay.
case, if you want to customize it,
Uh,
then what
but,
all
but,
changes
but
will be
for
required?
that, for that you need to have some, similar model. Because if you are having one model which was trained on images, then you cannot use it for text. So for that, you need to
Yeah.
have some model, some time series, model which was trained on LSTM or RNN or GRU. So you'll find
Mm-hmm.
various architectures for that, and then you need to customize it for your own task. Like if you want to generate a text or you want to predict something, then based on the similar architecture, you can do the customization.
So then in that case, this model will not be applicable. I have
Yes,
to
yes.
go for
This will not
something
be
else.
applicable. So
This is
first
only
thing
for the
is,
images.
yes, yes, it is for only for the images.
Okay, sir. Fine. It is available there, the repository which you were talking about.
No, this particular model is available as the part of applications package in our this Keras. So what I did for that, I just need to import keras.applications, and from there I can find this particular model. Or if you want, you can download it.
Keras.application is the link.
Yes, yes.
Okay.
And
So, or you were telling me the another way, huh? You can download
another
it from.
you just need to Google it. So you'll find it,
Okay.
one file which will be in the form of .h5 or .json, and then you can just use load model, and it will be loaded in your in some variable that you can further utilize for customization. So there are 7 8 architectures which are available as part of application. So these are already available. But if you want some other, pre-trained architecture and that is not available as part of Keras, then you can manually download it and load it uh, in your code and can utilize it for transfer learning. Is it clear?
So corresponding to different data which we are handling, we have got different applications in keras.applications available. We can pick out from there based on our application area which we are dealing with for
Yes, yes.
transfer learning.
Yes,
Yeah.
and if it is not available, it is not matching your, the data set you are working with or kind of problem you are, solving, then what you can do, you can go to Kaggle, and there you can look for similar problems and similar submissions.
Yeah, that's the
Because
unanimous solution. Yeah.
because you'll find some of,
Yeah.
kind of baseline models there, and
Mhm.
instead of training a model from the scratch, you can do some sort of
Mhm.
fine tuning on those models and come up with the solutions for that.
Okay. Fine. Thank you so much.
Okay, man. So is there any other question?
So can you share me your email ID, sir?
Yeah, sure.
Sir,
Yes, please go ahead.
how can we apply the transfer learning in case of videos, sir? In case of images, we can apply that. But in case of videos for summarizing and everything, how to apply that portion of transfer learning, sir?
Okay, so what is video?
It's a collection of images in frames. Correct.
Okay, so it can be applied in that way. Otherwise, what we can do manually, that we can process any type of data with the help of higher dimensional tensors. With the higher dimension tensors. So just read about this tensor, that if you want to process 5D data or if you want to process 6D data, so how it can be done. So as of now, if you want to process the videos, the one solution is to convert video into frames and then try to learn something from that. Suppose you want to do, the classification of activities, like what is happening in the video. So for that, what you can do, you cannot, enter the entire video, But what you can do, you can convert the video into the frames, or that can be done with some tool, like you are reading it with OpenCV, suppose from some camera. So it is getting you frames, and one frame at a time it is sending for the network or doing something like that. So this is one solution for that. And still there are people, because the video data set is very, very large, and even if we work with just the tensors, so the tensors give you uncompressed images, so the data, the size is very huge. Even if you are working with a video of suppose 10 seconds, and and if you convert that into a raw tensor format, so it occupies about 560 MB. So that was something that I did. I tested and I tried it. And suppose if you are having the multiple videos, so it is just about 10 to 15 seconds video. If you are having multiple videos, hundreds of videos, then the infrastructure that you have access to may fall short. So even the bigger giants, they are just devising the ways and means that how to perform training on the video data itself. They are still in the exploration phase. And still there is the biggest video analytics challenge, which is ActivityNet. So just Google it, ActivityNet, and there you will find lots of discussions and lots of material that how to do video processing as far as video surveillance is considered. So there are different models, there are different ways and means that how they are doing. Some people are using LSTM, some people are using temporal neural network architectures for doing that, and they are considering the images with temporality as the video, because there are some frames which are temporally correlated. One image is just logically related or sequentially related with other image. And there are techniques which are based on the optimization, that instead of taking all the frames, they are just taking sampling of the frames, because FPS is something which is frames per rate, and generally it is 60 or 30. So in 1 second video you'll get 30 images or 60 images. So it is not a good idea to process all those images because within 1 second there is very less changes occurring in the video. So you can sample out, you can take every 60th frame. So even if there is a video which is of 10 seconds and you are sampling out per second, so you'll be just having 10. Hello.
Yes, sir.
Okay, so the voice is clear, because I think someone is having issue with the voice.
No, sir, it is clear, sir. It is.
Okay,
Yes, sir, it is very clear.
Yes.
okay. I think Prasanta, there will be some bandwidth issue at your end, and you can utilize it. So what I can suggest you, it just to Google this term, which is ActivityNet, and it is the largest data set of video, and there is an annual competition which is on this ActivityNet, and you'll find lots of things on this. You can work with this, and there are different data sets available for this analytics. Like for activity recognition, we have sports 50 one data set. We have, I think, movies data set. We have this ActivityNet data set, which has three variants of it: ActivityNet 100, 200, and 500, based on its size. But it's the size of the ActivityNet data set is somewhere around 50 GB to 100 GB. So you should have computational power for that. But obviously you will find some of the interesting things related to this. And let me just show you this ActivityNet data set. Activate. So it is the largest scale video benchmark for human activity recognition, and there are various challenges for this. There is a challenge for untrimmed videos. There is activity instance classification data set as well, and then you can explore it. It is a long standing challenge, and there are different types of data sets available. So try to explore this particular website, and you'll get some of the download links. Like if you want to work with ActivityNet 100, which is the smallest size of the data that you can work with, there is ActivityNet 200, and there are other video data sets available. So you can start with some simple and some basic data sets on the activity, and you can explore it further. So I think you will even find some of the baseline models for video and image processing in PyTorch and in Keras. So for computer vision, if you want to work with videos, so I think PyTorch will be more convenient for you for doing this processing, because it is exclusively for computer vision, and it can give you many functions that can make your experience uh, a kind of less troublesome.
Thank you. That was very helpful. Thank you.
Okay, so anything else that you would like to ask, or we are just moving towards the end of the session? And I hope that I could add something to your learning, and we discussed some of the basic things. But as per my experience, uh, what mistake we do, we try to learn the very advanced things, but we should invest the proper efforts in making our concepts clear. So if we are comfortable with the basics, if we know the basics, then we can easily learn the high end things, because those are just the combination, those are just the a kind of cobweb of the smaller concepts. So if you are working in this field, then obviously you need to have command over one language, and Python is the language that can help you a lot. So have a very sound understanding of Python, how it works, and its basic libraries like NumPy and the pandas. So pandas is a very good library for pre-processing the data, for data wrangling, munging, and cleaning. It can help you a lot if you're working with some sort of structured data. Uh, then you need to have the understanding of your domain, because you'd be working only on one domain, and you can work only in one domain. Either you can work in natural language processing, or computer vision, or some sort of time series analytics, some financial data or something like that. So you need to understand the nature of that data, and then need to master 2 3 libraries for that. Like if you are into text processing, then there are various libraries for doing text processing, NLTK, uh, Gensim, and others. So you need to have understanding of those libraries, that how we can do various things, and how uh, uh, we can bring our data into a required format. If you are working with image data, then you need to have the basic understanding of various computer vision concepts, that how the images work, how the pixels can be modified, and how they can be processed, what are the dimensionality in images. And then you pick up one library for deep learning or machine learning, or tool that can help you. If you want to go in, uh, suppose a generic framework, then you can use TensorFlow and Keras. If you are interested in just for computer vision, then you can go with PyTorch. And there are other libraries available every day, day in day out. There are new tools, new technologies coming up. The cloud is there to be exploited. You can utilize its power, and then you continue to learn. And the best way of learning is to pick up a problem and try to solve it. So once you try to find the solutions of the the problems, the bottlenecks that you're facing, that is the actual learning. and at the end of some time you will also get some satisfying feeling that I have completed this much to solve this particular problem. And so that's it from my side for this session. I think it is ending at 1:15, or what is the time for this?
Yes, sir, 1:15.
Okay. So I do not want to stretch you further because you'll be having classes, planned for that. And I think this is the last day for this FDP.
Yes, sir.
Okay.
And this is the
So,
last session.
okay. So thank you for giving me opportunity to interact with all of you. It's a pleasure and privilege to be here.
We really thank you, sir, for your patient explanation of each and every concept precisely. And the most aspiring part is that time when you started at 10 o'clock, the energy levels you maintain has been perfectly maintained till the last second of this your speech. We really this is a strong motivation and the passion which you had it for the subject, and I hope that each and every participant has been benefited much from Dr. CM Sharma's sessions, and we really thank a bunch for accepting our invitation and being a part of this FGP covering 3 major advanced sessions. Thank you very much, sir.
Thank you so much.
And I look forward to invite you regularly in by every event, whatever we conduct it related to the data science and machine learning.
Thank you so much for extending. So I'm sharing my email ID. If you would like to contact me even afterwards, then you can write me to my personal email ID. This is cmsharma.cdday@gmail.com. Thank you so much, and have a good day ahead.
So I request all the participants to be available by 2:15 p.m. today for the validatory function. The validatory schedule will be shared to all of you within few minutes. And we start the validatory by 2:30, and by 3:30 we'll start the test. So the test contains, I repeat, the 3:30 p.m. today, the test will be there. But before that, I request all the participants to be available for the validatory, and we start the meeting by 2:15. So please join the meeting by 2:15. And 2:30 we start the validatory in time and finish by 3:15 or so. And we start the test by 3:30 sharply. So the test contains 30 multiple choice questions, out of which you should secure minimum 18 to get a certificate. And the test is not that much complex. I wish you good luck. And the test automatically closes by 4:30. So make sure that it's a 1 hour time. Earlier I told it's half an hour, and many participants have requested for increasing the time. So we put for 1 hour. So the test automatically gets closed by 4:30, and the responses will be considered only be up to 4:30, whoever has submitted. So keep that in mind and answer your queries. And I request all of you to maintain a honesty code while taking the test. Thank you very much. And we'll join back at 2:15 sharply.
Sir, this form is not supporting, sir.
And the test is only for the registered and approved participants. I repeat, the test is only for the registered and approved participants. Only these participants will get the certificate once they clear the test from the AICTE. So the test is for only the registered and approved participants, and they only will be receiving the certificate if they clear the test. And the farm currently will not accept the responses. It will start responses accepting from 3:30 p.m. onwards today.